In this video, we are going to perform a repeated measures one-way ANOVA in Stata, also known as a within subjects ANOVA. This is a test that you should use when you want to determine whether three or more group means are different, when actually the participants are the same. Here is a data set that we are going to use for this demonstration. We have a total of 15 participants undergoing a hypertension treatment, and their systolic blood pressure was measured at baseline, and their values are recorded here. We have the same participants again measured after 1 month of treatment, and again after 3 months of treatment. Their respective values are also recorded here. This type of data is what we refer to as the long format. And for you to run the repeated measures one-way ANOVA, we should have our data in long format as opposed to the wide format. In the wide format, we would have our subjects listed from 1 up to 15, the measurements for baseline, then for month 1 and month 3. We have a separate video that shows how to restructure your data set from wide format to the long format for you to be able to run the one-way repeated measures ANOVA in Stata. Be sure to check it out. So the question we are attempting to answer in this analysis is, do we have significant differences in the mean blood pressure measurements at the different time points, at baseline, month 1 and month 3. To run the repeated measures one-way ANOVA in Stata, simply go to Statistics, Linear Models and Related, then choose ANOVA MANOVA and Analysis of Variance and Covariance. In this dialog box, we are going to specify the dependent variable, that is blood pressure. Then within our model, we shall put the subject ID, which uniquely identifies each participant, and we shall also put the time element, which shows the repeated measurements. After that, we tick this box that shows repeated measurements variable, and we specify that this is the time variable. Then we click OK. In our output, we have the command up here, and then we have the ANOVA table that shows our variables, all sorts of variation. We have the partial sum of squares, degrees of freedom, the mean squares. We have the F statistic, and then the p-value. Our interest here is this p-value corresponding to the variable time. But before we interpret this variable, there is one important assumption of a repeated measures one-way ANOVA or ANOVAs generally, that is the assumption of equivariance of the differences, commonly called the Cephalisti assumption. This is tested using the Mochilis test of Cephalisti, which we shall spare for another day. If the Cephalisti assumption is violated, we opt for the different options for correcting this. There are about 4, but commonly we use the greenhouse geyser option, which has its p-value stated here. You can see that for time, greenhouse geyser is also statistically significant. So back to our table, assuming our assumption has been fulfilled, we see that the p-value is less than 0.05, indicating that there are significant differences in the mean systolic blood pressure measurements at the different time points. However, from this analysis as it is, we cannot tell which group mean is statistically different from the other. Therefore, we have to run the post hoc tests to tell us where exactly these differences lie within our groups. To do this, we shall go for post hoc estimations. It is important to note that these post hoc test analyses are run on the model that has just been performed. To run these post hoc tests, simply go to Statistics, go down to post estimation. Then in this dialog box, we are interested in tests, contrasts, and the comparison of parameter estimates, and we select the pairwise comparisons. We specify here the factor terms to compute pairwise comparisons for, and that is time, which we saw that there are statistically significant differences in the different time points. Then under multiple comparisons, by default is do not adjust, but here we want to adjust using the Bonferroni method. There are several other methods that you can interest yourself in. For now, we are choosing the Bonferroni method and then click OK. Within this output, I would also want to get the p-values. So still under pairwise comparisons, under reporting here, I'm going to check the specify additional tables, and I will choose show effects with confidence intervals and p-values. Then click submit. So like we saw that time was statistically significant. Now this is a more detailed pairwise comparison that shows you that month 1 versus baseline, the mean difference is 6.9, which is statistically significant, meaning month 1 was significantly lower than baseline, because it is month 1 minus baseline to give you that value a negative. Similarly, we can see that month 3 versus baseline, it is also statistically significant. So the mean systolic blood pressure measurements at month 3 were significantly different from baseline. However, when we come to month 3 and month 1, the difference is only 4.4, and this is above 0.05, which is non-significant. That's implying that the measurements at month 3 and month 1 were not significantly different from each other. We can even go ahead and obtain these means to better understand what is being presented here. Go to statistics, summaries, tables, and tests, then summaries again, and select means. So we want means for the variable blood pressure, but we want to group by time. Okay, then click OK. You will see that the mean at baseline was high at 120. Then after 1 month of treatment, it is 113. And the difference between baseline and month 1 is what is shown here, close to 7, which is statistically significant. When you look at month 3, the mean blood pressure measurements were even lower, and when you get the difference between this value at month 3 and baseline, that is almost 11.4, which is statistically significant. But when you look at 113 and 108, these are close to each other. That's why there is this non-significance here. So here is a template that you can use for reporting the results of the repeated measures one way, ANOVA. If you found this video useful, consider liking, subscribing, and commenting to the video so that you don't miss out any of our subsequent episodes. Next, we shall look at the two-way ANOVA in Stata, a test that you should use when you have two independent categorical variables versus one outcome numerical variable. See you in the next episode.